Yeah, very good afternoon, students. Good afternoon, Ashwin, and good afternoon, Jamie and students. So, am I audible and visible to you guys? Can you able to see the screen? If everything is okay, just type yes in the chat box or give me a thumbs up. Yes. Okay, fine, good. So now today will be the last session for the solutions lesson. Okay. So yesterday we have completed this lesson, and today we are going to solve numericals, that is problems, based on all the topics that we have seen in this lesson. Okay, so mixed problem solving will be done today. Okay, so from tomorrow onwards, we can start with the new lesson. Okay, so let's start with the first question for today. So all the questions which I'm going to discuss here are the previous year's questions of NEET and JEE. Okay, so here is the first question for you. The KH value for some gases at the same temperature are given, where KH is the Henry's law constant in water. The order of their solubility in water is. So KH value is given, Henry's constant value is given in the question. We are asked to find out the order of solubility. Can you guys try for this and let me know the answer in the chat box? I'll give you 15 to 30 seconds to solve this question. Try for this and recall what are the things we have discussed here in with KH and solubility, and try to get the answer, and let me know the answer in the chat box. Take some time and do it. After some time, I'll discuss this with you. Has anyone got the answer here? No? So what is the relation between KH and the solubility? KH is inversely proportional to solubility. KH is inversely proportional to solubility. So the gas which is having the highest KH value will be least soluble. Okay. Now here you check in the question which is having the highest KH value. It is argon. Means it is the least soluble one. Then comes carbon dioxide 1.67. Okay. So after this we will have CH4. It is just 0.4. So CH4. And then we have 1.83 into 10 to the power minus 5. Minus 5 means it is 0.0001. Okay. So at last only HCHO will come. So where do we have this option? It is given in option D. So option D is the correct answer for us. Okay. So just we are applying only one relation here to solve this question. Okay, very easy question it is. Shall I move on to the next question? Do you have any doubts here in this question? Will you be able to solve if this is being asked in the upcoming examinations, or if a similar type of question is asked in your upcoming examinations? Yes or no? Say something. Shall I move on to the next question? Is this clear? Students, give me some response. Don't stay silent. Okay. I'll proceed with the next question. The correct option for the value of vapor pressure of a solution at 45 degrees Celsius with benzene to octane in molar ratio 3:2 is. Vapor pressure of benzene is given and vapor pressure of octane is also given, and we have to assume this as ideal gas. Now, how to solve this question? How to solve this? We have to find out the vapor pressure of the solution. We have to find out the vapor pressure of the solution. That is the total vapor pressure we have to find out. It is equal to PA naught into XA plus PB naught into XB. Okay. So component A is benzene. It is taken as benzene, and component B is taken as octane. Okay. Now, the vapor pressure of the pure benzene, PA naught, is given as 280 mm of mercury, and we have to find out XA. How to find out XA? XA is nothing but the mole fraction. It is equal to Na divided by Na plus Nb. Okay. The number of moles of benzene to octane ratio is given here as 3:2. So for benzene, the number of mole is 3 and 3 plus 2 will be 5. So XA is equal to 3 by 5 plus PB naught. So the vapor pressure of octane is 420 mm of mercury into XB is 2 by 5. Okay. If we solve this, what we will get? 5 and 6, and here 5 and here it is 1 and 8, 4, right? Now, it is 5 into 3 into 6 is 18, 168 plus 168. So what we are getting? We are getting 336 mm of mercury as the vapor pressure of the solution. So option D is the correct answer for this. Okay. So in all the problems, we are applying only one formula. So try to concentrate on those things which is given and which is being asked, and think of the formula which has to be used in the question and do it accordingly. Okay. Shall I move on to the next question? Shall I move on to the next question, students? Yes or no? Pratyusha, did you understand this question? Ashwin, what about you? And the JNV admin students, what about you? Yeah, fine. So coming to question number 3. Okay. So the mixture which shows positive deviation from Brown's law is. So we have studied ideal solution and non-ideal solution, right? And in non-ideal solution, we do have two types. One is positive deviation, and the other one is negative deviation. And under each case, we have studied the examples. Now, which one is the correct pair of example for positive deviation? If you have studied the examples under each type, you might have given me the answer by now. Has anyone got the answer? This is an example for positive deviation here from Raoult's law. Option A, B, C, D. Which is the correct one? Try for it. Try for it. Very good, Ashwin. Very good. Great. Option D is the correct answer. So the example is ethanol and acetone. Very good. Let me move on to the next question. The Van 't Hoff factor I for a dilute aqueous solution of the strong electrolyte barium hydroxide is. So yesterday when I was discussing about the Van 't Hoff factor, I told you no. So barium hydroxide. So what we have to do? We have to dissociate this. Then how does it get dissociated into their corresponding ions? If we treat this in a dilute aqueous solution, it will be converted to Ba2 plus and 2OH minus. It is Ba2 plus and 2OH minus. So we have one cation and two anion. So the total number of ions produced, I is equal to 3. I is equal to 3. So the correct answer is option D. Okay. So for any type of salt, given, what you have to do, you have to just separate that into cation and anion and count the number of ions and put it. That is Van 't Hoff factor. Okay, very easy question. Now we'll move on to the next question. Which one of the following electrolytes has the same value of Van 't Hoff factor as that of Al2SO4 thrice? How to find out? Just now I have said no. To find out the Van 't Hoff factor, we have to first dissociate the compound. It is Al2SO4 thrice. It will be dissociated like 2Al3 plus 3SO4 2 minus. So yesterday I have given you that formula, right? Ax and By. So for this type of solve, we have to dissociate the thing like x into a power y plus y into b power x minus. So this is the general formula for all the dissociation of a salt. Okay. Now how many ions are generated? 2 cation and 3 anion. So totally the I value is equal to 5 for aluminum sulfate. Now we have to check for the options, given options which has I value 5. So what is I value for option A? So we have 1 aluminium and 3 NO3. So it is Al3 plus 3 NO3 minus. So it is 1 plus 3. Here we are getting 4. No, that cannot be the answer. And when you check for option B, we have 4 potassium and 1 coordination entity, FeCN6 minus. Okay, 4 minus. So we have 4 cation and 1 anion, which will give us the value 5. So here we are getting the value as 5. So option B is the correct answer. So option B is having the same value as that of A into SO4 threads. Okay. And coming to K to SO4. So it will be 2K plus and 1 SO4 minus. So it is 2 plus 1. So 3. And coming to option D, we have 3 potassium plus FeCN6, 3 minus. Okay. So it is 3 cation plus 1 anion. So the answer is coming out to be 4. So only option B is having the I value as 5 as that of A into SO4 phase. And that is the correct answer. Clear for all of you? This is very easy. Okay. You don't have to struggle. Just find out the I value by calculating the number of ions produced. That's all. Okay. So I'll move on to the next question. Do any of you have any doubt from the Van't factor part? I have solved now from this question and from the previous question. It's very easy, no? Is it clear for all? Just give me your answer in the chat box. Is everything clear for all of you? Jain V. Ramnagar students and Jain Mianam, Ashwin, Anand, Pratyusha. Is everything clear? Which we have discussed so far. Shall I move on to the next question? Yes. Okay. Coming to this question. 200 ml of an aqueous solution of a protein contains its 1.26 gram. Osmotic pressure of a solution at 300 Kelvin is given as 2.57 into 10 power minus 3 bar. The molar mass of the protein will be. Now, how to find out this? We have to find out the molar mass of the protein using osmotic pressure formula. What is the formula to find out the molar mass from osmotic pressure? Molar mass of the protein which is solute is equal to mass of the protein divided by pi into B into RT. So this is the formula, right? So what is the mass of this protein? It is given as 1.26 divided by osmotic pressure value is found out to be 2.57 into 10 to the power minus 3 bar into volume. So volume is given in terms of 200 milliliter, but we have to give in terms of liter. So just to put 200 divided by 1000, okay? And we have R in the numerator and R value is 0.083 and the temperature is 300 Kelvin, okay? Now you have to solve this. Now we have to do all the multiplication and division part here. So if you do everything, the answer you will get is 61038 gram per mole. Okay. So please try the multiplication division part of this question and check whether you are getting this answer or not. Okay. So do practice it. So this is the molar mass of the protein. Option D will be the correct answer. Okay. Just direct substitution into the formula. Given values into the formula. That's all. Okay. Shall I move on to the next question? Shall we go with the next question? So today we are solving the numerical problem solving part of the entire lesson. Okay, today we will complete this lesson. For the people who have joined late, I'm telling for them. Okay, we are solving the problems from the entire solutions lesson. Okay, so now I'll move on to the next question. The Van 't Hoff factor I for a compound which undergoes dissociation in one solvent and association in other solvent is respectively. Yesterday I gave you the relation. So what is the relation? Can anyone give me the correct answer for this question? Let me see who's having all the things that I have discussed so far yesterday. Do any of you remember? For dissociation, the I value will be greater than 1 or less than 1. And for association, is it greater than 1 or less than 1? What is the answer for dissociation? For dissociation, the I value will be greater than 1. Okay. And for association, the I value is less than 1. So which is the correct answer? Option C is the correct answer. Okay. The straightforward theory questions. That's all. Nothing to do with mathematical part here. Okay. The next question. The freezing point depression constant Kf of benzene is 5.12 Kelvin kilogram per mole. The freezing point depression for the solution of molality 0.078 molar containing a non-electrolyte solute in benzene is rounded off up to 2 decimal places. And we have to find out the freezing point depression for the solution. Okay, freezing point depression. So that will be calculated using Kf into M. Freezing point depression, delta Tf, we have to find out. It is equal to Kf into M. So Kf is given as 5.12 and M is given as, molality is given as 0.078. And if you multiply these two numbers, what you will get, students? Can anyone multiply and give me the answer in the chat box? Can anyone try the answer for this? Just try and let me know. Give a try, all of you give a try. Already we have solved this question when I was discussing the freezing point depression constant, right? In that day itself we have solved. Which is the correct answer from here? Option A, B, C or D? 5.12 into 0.078. Very good, Pratyusha. The correct answer is, actually you'll get some 0.3999 something you'll get. So it will be approximated to 0.40 Kelvin. Okay. Very good. Option B is the correct answer. Now coming to the next question. So this is the J question. So here we have to find out the weight of glucose. What weight of glucose must be dissolved in 100 gram of water to lower the vapor pressure by 0.20 mm of mercury? Okay. Assume dilute solution is being formed and the given values are the vapor pressure of pure water at room temperature, molar mass of glucose. So these two values are given. We have to find out the mass, that is the weight of the glucose. Glucose is the solute here and water is the solvent here. Okay. So to find out the mass value, so we know that number of moles is equal to mass divided by molar mass. So from this, mass is equal to number of moles into molar mass. Okay. So we need to find out the number of moles and we need to find out the molar mass of this substance. So molar mass is given here as 180. Okay, it is given as 180 and we have to find out the number of moles of this glucose. Okay. So let me come from this relative lowering of vapor pressure formula. Okay. So P naught minus Ps divided by P naught is equal to number of moles of the solute divided by number of moles of the solvent. So this is the formula which we have to use for dilute solution, right? Which we have to use for dilute solution. And the change, if you see, the lower The lowering of the vapor pressure is by 0.20. Lowering means the difference, it's delta P. So it is equal to 0.2 divided by the vapor pressure of the pure water. This is for pure water, no? So for pure solvent, it is 54.2, which is equal to number of the moles of the solute. That only we have to find out. And this is the number of moles of the solvent, which is equal to the mass of the solvent divided by molar mass of the solvent. And that molar mass will go here, molar mass of the solvent. Okay. So what I'll do? N2 into molar mass of the solvent. Solvent is the water, okay, which we have 2 hydrogen. So 2 into 1 will be 2, and only 1 oxygen we have. So 1 into 16 is 16. So the molar mass of oxygen is 18. Molar mass of the solvent is 18 divided by mass of the solvent. So mass of the solvent given here is 100. Okay. Now if we solve this, we will get N2 as 100 divided by 271 into 18. Okay. Now substitute this value in place of this number of moles. So the equation becomes like, okay. So mass of the glucose, mass of the solute is equal to number of moles of the solute, which is 100 divided by 271 into 18 into molar mass of the solute. Molar mass of the glucose is 180. And you can solve directly here. Okay, so 1000 divided by 271 will come, and from this you will get M2 value as 3.69 gram. 3.69 gram, in which option B will be the correct answer. Sorry, it is C. It is not B, it is C. Okay, option C is the correct answer. 3.69 is the mass of glucose. Clear for all of you? So we need the number of moles to find out the mass of glucose. So I am calculating that number of moles value from the relative lowering of vapor pressure formula. So since the solution is diluted, so here we have to assume the solution is dilute solution, no? So I am using this formula. Clear for all? Shall I move on to the next question? Yes or no? Do any of you have any doubts from this? Okay, the next question is, in the depression of freezing point experiment, we have 4 statements. Okay, we have to find out the correct statement. So in the depression of freezing point experiment, the vapor pressure of the solution is less than that of pure solvent. And the second option, second statement, it says that it is more than that of pure solvent. And C says only solute molecules solidify at the freezing point. And D says that only solvent molecules solidify at the freezing point. So let me show you the graph which we have studied for depression of freezing point. Okay. So here this line corresponds to the solvent line, pure solvent line. And this line corresponds to the solution line. Okay. Now you check. Vapor pressure of the solution is less. Vapor pressure of the solution is less compared to vapor pressure of the solvent. Yeah, that is correct. If that is correct, then statement B will be incorrect now. Then coming to statement C, only solute particles solidified. No, only the solvent particles are getting solidified. Solvent is getting frozen. Okay, so option statement D is correct and statement A is correct. So option A is the correct answer for this question. Clear? Clear for all of you? Shall I move on to the next question? Shall I go to the next question? Okay. So here is the next question. A solution containing 2 gram of a non-volatile solute in 20 gram of water boils at 373.52 Kelvin. Okay. So boils means it is the boiling temperature, TB value. and this is the mass of the non-electrolyte. The molecular mass of the solute is, so water boils at 373 Kelvin. So this is the boiling point of pure solvent. So TB naught, Kb is also given. We have to find out the molecular mass. So how to find out the molecular mass? M2 is equal to Kb into W2 into 1000 divided by delta TB into W1. Okay. We have Kb in the question, mass of the solute in the question, and we have to find out the delta TB. Okay, we have the mass of solvent also. W1 is also given. Okay. So now the delta TB can be calculated from TB minus TB naught. Okay, for boiling point, it is TB minus TB naught. So TB is nothing but 373.52 and the boiling point of water is 373, boiling point of the solvent. So it is coming out to be 0.5. So substitute this delta TB value here in this formula. So Kb is 0.52 and mass of the solute is 2 gram into 1000 divided by delta TB is 0.52 into mass of the solvent is 20. So 0.5 to 0.52 gets cancelled. Okay. Each 0 and 2 will get cancelled. So the remaining molar mass is equal to 200. Sorry, it is 100. No, it is 100 gram per mole. It is 100 gram per mole. The molecular mass of the solute is 100 gram per mole. Okay. Clear? Shall I move on to the next question? The next question says that the total pressure of a mixture of non-reacting gases X and Y in a vessel is 740 mm of mercury. The partial pressure of the gas X is dash mm of mercury. So we have to find out the partial pressure of the gas. So the pressure of the gas can be calculated using mole fraction of the gas into the total pressure. Into the total pressure. So what is the mole fraction of the gas? It is number of moles of that gas divided by total number of moles. So this is the formula. Number of moles is again written as mass by molar mass. So the given mass of X is, 1 is 0.6 divided by the molar mass is given here as 20 for X. Okay, the whole divided by again 0.6 by 20 plus number of moles, mass of the solute. Mass of the solute is given as 0.45. 0.45 divided by the molar mass of the solute is given as 45. It is 45. Okay. Now it will be equal to 0.03 divided by 0.03 plus 0.01, which is equal to 0.03 divided by 0.04, which is equal to 0.75. Okay. So the partial pressure of the gas is mm of dash mm of mercury. That dash 0.75 has to come. Okay. Clear? Oh, sorry. This is the mole fraction, right? So this is the mole fraction value. 0.75 is this is the mole fraction value. And we have to substitute this mole fraction here in this formula to find out the partial pressure of the gas. Okay. So now the partial pressure of the gas is equal to the mole fraction, which is 0.75 into the total pressure. So the total pressure here, it is given as 740. Total pressure is given as 740 in the question. So 0.75 into 740 will be equal to 555 mm of mercury. Okay. So only one formula. We are using only one formula to find out the partial pressure using the mole fraction and total pressure. So you have to look into the question first. Then only you can select the formula. Clear? Clear for all of you? Shall I go with the next question? Yes? The next question is the gaseous mixture of two substances A and B under a total pressure of 0.8 atm is in equilibrium with an ideal liquid solution. So gaseous mixture is in equilibrium with ideal liquid solution. The mole fraction of the substance A is given in vapor phase and it is 0.2 in liquid phase. Mole fraction is given in terms of vapor as well as liquid. Now the vapor pressure of the pure liquid A is dash atmospheric pressure. So how to approach this? So we have YA formula, YA value, okay, mole fraction of A. In vapor phase, we have to denote it as Y naught. So that's what we have studied in the theory part of this lesson. It is 0.5. And in liquid phase, for mole fraction liquid phase is written as X. So XA is equal to 0.2. Now what else is given? The total pressure is given. So P total is equal to 0.8 atmospheric pressure. Okay. And we know that PA is equal to YA into P total, which is equal to 0.5 into 0.8 and it will be equal to 0.4. So I have got the value of PA here. Now, according to Raoult's law, PA is equal to PA naught into HA. Okay, PA naught into HA. So PA is 0.4. So from this, what is PA naught? PA naught is equal to PA divided by XA. So what is PA? 0.4. And what is XA? The mole fraction of A. What is the mole fraction of A? It is 0.2. It is given in the question. No, mole fraction of A it is given as 0.2. So the answer is coming out to be 2 atmospheric pressure. So what is this 2 atmospheric pressure? It is a value of the vapor pressure of the pure means substance. Okay, substance E. Clear? So the answer is option 2. The vapor pressure of the pure liquid A is 2 atmospheric pressure. Clear, guys? Can you all able to understand what I'm trying to say here in this question? Yes or no? Yes. Okay. So the next question is, the elevation in boiling point for 1.5 molar solution of glucose in water is 4 Kelvin. The depression in freezing point for 4.5 molar solution of glucose in water is 4 Kelvin. The ratio of molar elevation constant to the molar depression constant is. So what we have to find out? The ratio Kb by Kf we need to find out. So let me take the relation. Delta Tb is equal to I into Kb into M. So delta Tb by delta Tf is equal to I into Kb into M divided by I into Kf into M. So I and I gets cancelled. So here the change in the boiling point and freezing point. It is given as 4 Kelvin, 4 Kelvin. So 4 by 4 is equal to Kb by Kf into molality. Molality is given as for boiling point it is 1.5 and for freezing point it is 4.5. Okay. From this Kb by Kf is equal to 3. The answer will come out to be 3. The ratio of molar elevation constant to molar depression constant Kb by Kf is 3. Here I have related the delta Tb and Kb formula. That's all. Now these are the JEE mains questions. Will I go with the next question, students? Is it okay? Clear for all? Is it clear for all? Okay. Now the next question is, an aqueous solution of volume 300 centimeter cube contains 0.63 gram of protein. Okay. 300 centimeter cube is the volume and 0.63 is the weight of the protein. The osmotic pressure of the solution at, so 300 Kelvin is the temperature. Osmotic pressure is given as 1.29 molar. Osmotic pressure is 5. The molar mass of the protein. Molar mass of the protein is what? So again, how to find out? 1.29 millibars. So how to find out? So we know that molar mass of the solute is equal to mass divided by pi into V into R into T. Okay, so the mass of the solute is given as 0.63 into R value is given as 0.083 into temperature is given as 300 Kelvin divided by pi value. Osmotic pressure value is 1.29 millibar. So I have to put that millibar. Okay, it is into 10 to the power minus 3. Okay, it is 10 to the power minus 3. Clear? Into what is that? Volume. So volume is given as 300 centimeter cube. So centimeter cube has to be converted to meter cube. So it is 300 into 10 to the power minus 3. Okay, 10 to the power minus 3. And if you solve this, you will get the molar mass of protein value as 40535 gram per mole. 40535 gram per mole as the answer. Okay, just you need to concentrate on the units. So here we have millibar. So I am multiplying it by 10 power minus 3. Okay, so those things has to be noted down here. You have to check for the units while solving the physical chemistry problems. You have to check for the units also. Clear? So without seeing the units, if you are solving the question, you may get the answer. Okay, but you will not get the correct answer. So just concentrate on it. Shall I move on to the next question? Is it clear? And have you copied this? Yes. Okay. Lead storage battery contains 38% by weight of weight solution of H2SO4. The Van der factor is 2.67 at this concentration. The temperature in Kelvin at which the solution in the battery will freezes, and Kf is also given. So to find out the freezing point, I need Tf and Tf, delta Tf. So how to find out delta Tf? It is equal to I into Kf into M. Okay, I value is given as 2.67 Van der factor, and K value is also given as 1.8 into the small m is called as molality, which is equal to number of moles of solute divided by mass of the solvent in kilogram. What is the number of moles of solute? From this information only we have to take. So 38% by weight solution means 38 gram of the solute is present in 1000 ml of the solution. So number of moles is written as mass by molar mass. So the mass of the solute is 38 divided by the molar mass of the solution H2SO4. How to find out the molar mass? To H2SO4, 2 hydrogens, so 2. Only 1 sulfur, so it is 32. We have 4 oxygen. So what will be the value for 4 oxygen? 16 into 4 is how much? 64, right? So 64 is the, this is for oxygen, and the 4, 6, 116. Just one of you check here. One of you check the molar mass of sulfur, H2SO4. This is 8, no, this is 8 actually. This is 9, yeah. 98 is the molar mass of the system, and we have the mass of the solvent also. So mass of the solvent has to be calculated. So 38 gram is the mass of the solute. Now to find out the mass of the solvent, I have to do 100 minus 38, and this will give me 62. So 62 is the mass of the solvent, which I have to substitute here. Okay, now everything is ready, but I have to put, denominator, I'll get 1000. So that will go to the numerator. So it is 1000 here. Okay, now if you solve this, and you will get 30.05 as the value of delta F. But we are asked to find out the freezing point. So freezing point is equal to TF minus delta TF. TF minus delta TF. Okay, TF is the freezing point of water and delta TF we have calculated. Okay, so it is equal to, this is TF naught, no, TF naught. So freezing point of water is 100 degrees Celsius, means it is freezing point of water is 0 degrees Celsius, so it is 273 Kelvin minus 30.05. Okay, and this will give around 243 Kelvin. This will give you 243. So now the freezing point is 243 Kelvin. Okay, the temperature in Kelvin at which the solution in the battery will freeze. So the freezing point is 243 Kelvin. Okay, clear? Freezing point of the solution, TF is calculated for this. Now coming to the next question. 1.80 gram of solute A was dissolved in 62.5 centimeter cube of ethanol, and the freezing point of the solution was found to be 155.1 Kelvin. The molar mass of the solute is given, freezing point of the solvent is given, density of the solvent is given, freezing point depression constant of the solvent is also given. So everything is given in the question. We are asked to find out the molar mass, that's all. Okay, so the molar mass of the solute in terms of freezing point. So that is equal to M2 is equal to Kf into W2 into 1000 divided by delta Tf into W1 in terms of gram. Okay. So from the density only we are going to find out the mass. So we know that density is equal to mass by volume. Okay. From this, what is mass? Mass is equal to density into volume. Okay. What is the density of ethanol? It is 0.80. What is the volume of ethanol? It is 62.5 centimeter cube. The 62.5 centimeter cube. So it will be equal to 50 gram. If you solve this, you will get 50 gram. So 50 gram is the mass of the solvent. Solvent is ethanol, no? So it is denoted as 1. So W1 is equal to 50 gram. W1 is equal to 50 gram. Then what else I need? W1 I have calculated, and I have to find out delta TF also. Delta TF is equal to TF naught minus TF, right? So TF naught means the freezing temperature of the solvent. Solvent is the ethanol. So the freezing point of ethanol is 156 minus freezing temperature of the solution. So the freezing point of the solution was found to be 155.1 Kelvin. Okay. So if I subtract this, I will get 0.9. So I have delta TF and I have the mass value, everything I have, just substitute. So the molar mass of the solute A is equal to Kf. Kf is called, Kf is 2. Freezing point depression constant Kf is 2 into W2, mass of the solute. Mass of the solute is 1.8 into 1000 divided by delta TF is 0.9 into mass of the solvent is 50 gram. Okay. Now we can solve this. Okay. 5 and here 20 will get, okay, 40 into 1.8 divided by 0.9. So the final answer will come out to be 80 gram per mole. Final answer is 80 gram per mole. So the molar mass of this solute A is 80 gram per mole. Okay. So this is the final answer. Can you able to understand this question, students? JEE Mains 2022 question. So we are provided with many values and we have to find out the molar mass. So delta TF and mass of the solvent we are finding from the density formula and delta TF formula, and we are applying it in the molar mass formula and getting the answer here. Is this clear for all? Do any of you have any doubts from this question? Tell me, students, do any of you have any doubts from the from this question? So this is the last question for today, and I hope the entire solutions lesson is clear to all of you who are watching here. Okay, so you can still go home and you can study this lesson thoroughly. And if you are getting any doubts, feel free to ask the doubts from this lesson in the upcoming classes also. Okay, so this is a physical chemistry lesson in which you have to solve at least one or two questions by this time. Okay, every day. Every day you have to solve. At least one question you solve from this lesson. Okay, so then only you will have a touch. Then only you will not forget the formulas. Okay, make a flow chart. So we have divided this lesson into two. The first half talks about all the laws, Henry's law, Raoult's law, ideal solution, non-ideal solution, concentration term formula. So everything will cover in that first part. And the second half of the lesson is colligative property and Van 't Hoff factor and abnormal mass. So this is the second half, and write all the formulas which we have studied under each topic and make a flow chart in a single sheet, paste it in your notebook or in your home, anywhere you can paste it, okay? Or maintain a file. So whenever you are free, just open that and go through the formulas so that you will not forget. Okay, so you will not get confused at the end of the day. Clear? So from the beginning itself, study properly, have a consistent study. As I have already told you in the first class, consistency is very important. Okay, whether it is physical, organic or inorganic, every day you have to study the things which we are discussing in the class. Got it? So tomorrow we will start with a new lesson. Tomorrow I will discuss electrochemistry. Okay. So any doubts from the today's numerical part of solutions lesson for anyone? Is everything clear? Everything is okay? Fine. Yes. Thank you so much, Jamie Adam students, for your response. I hope others are also okay with this and feel free to ask your doubts. Okay. Thank you so much, students. Thank you so much for listening. See you all in the next class. Take care. Bye-bye. So one more thing, JNB RCR students, you have asked me about the videos, no? Videos in YouTube. Videos in YouTube, right? So this